Slow. Oh no. Got a couple of goods. Slow. Oh no. Okay. It is a really nice day. I went for, yeah, a nice long walk this morning. So nice to get out and not have to like be like freezing during the whole time I was walking. Let's see. I want to get into here. Hopefully I can speed up the class for you a little bit, Luke, so you're not, we can get to the evening a little bit faster on said Tuesday. Let's see, I need to go over into here, and I think you guys are there already. So I just want to take a couple minutes here just to get everybody up to date with some of the updates that I've done over the weekend and the last couple of days. So lots of things kind of coming through the woodworks. I've had a lot of time now to do some recording of videos for you. So in the simple interest section, I've had the chance to update some of the links here for the last couple classes. So if you want to see another couple examples on, for example, how to use time diagrams, talking about equivalent payments and things like that, there's a couple links here to the online version of the textbook that now has some updated videos for you. So that is there. And I'm starting to work on getting some information up for compound interest now as well. But the nice thing is that quite a few of these videos are fairly easy to find online. So I might be able to just post some extra content here for you for online as well. Please have on your agenda that we do have the test coming up relatively soon. So the test is upcoming on October the 28th. And there is some practice that is posted for you. So there's a practice test, the solution key to the practice test. Please know that there are a couple errors on the solution key. I just haven't had enough time to update the solution key this year to account for those two errors. So just be mindful of that if you do go through the solution key. And the test is going to be set up pretty much the same as the first test. So we're looking at, there's going to be 1, 2, 3 parts. There's going to be a Dropbox for you to submit your work when you are completed. And what I've done, kind of based on some feedback I heard from students in the last class, is I've just upped the time limit a little bit. So now instead of 20 minutes, all of the parts will be available for 25 minutes instead, just giving you a little bit of extra buffer time to finish those questions. Hey, no worries, no worries. So same format as the last test, 12 to 6. I'll be available from 2 o'clock to 4 o'clock on that particular day. If you have any questions via the Zoom link. So yeah, all of that is up and running. I'll try to get a practice test. So I know I've had a couple questions about getting a practice quiz up for test number 2 as well. So I'll look into getting that going for you guys as well. And then the last thing on the docket before we move into class today is assignment 3 has been posted. It's under the annuities section. So it's there. It's going to be very similar to assignment number 1, where I'm going to ask you to do a couple computations, upload that via PDF, and then kind of work through some of the computations in a video format. So same as assignment number 1, will be marked using the same rubric as assignment number 1. Use the group choice to tell me which question you'd like to work on, and then the Dropbox will be there for you to upload both of the PDF as well as the video, or you can send me a YouTube link as well, as I know some of you did for the first assignment. So that's there. It's not technically due till the 5th of November, so you got a little bit of buffer time. If you don't want to look at it until after test number 2, that's totally fine as well. But after today's class, you should hopefully be in pretty good shape to tackle the third assignment if you want to use it as a way to review some computations for the second test. So that's available. And if you have any questions about that, let's save questions for the assignment until next week so that we can kind of start trucking our way through some compound interest problems. That's really what I want to get to today. I really want to talk about future value of compound interest. Now, you can correct me if I'm wrong. I believe we left off here during the last class, which would have been last Thursday. So we're talking about, I think, so just let me know in the chat. I don't think we had actually completed this question at all, right? We had just kind of stopped here. I said, copy the question down, maybe look at it. Okay, so if that is the case, I would like to just get this set up and completed for you guys. So let's start by just constructing the time diagram. So we have a bit of a better idea of where to move our money around. And I'm just going to grab a ruler here. And let's try to figure out what kind of timestamps we'd like to have along this horizontal line. So I do believe we have a today date. And so what we're going to do is we're going to pay $10,000 today. And in the future, this investment is going to give us 2 equivalent payments. So it's going to give us an equivalent payment 1 year from today and 2 years from today. And then after that 2-year time period, there's going to be $0 left in this account. So that's kind of the framework here. We're going to pay $10,000 today. We're going to invest into this thing at a fair market value of $10,000. And then after the span of 2 equivalent payments that happen, one in the 1-year mark and one at the 2-year mark, I'm going to end up with $0 after that second payment comes back out to me. So what do we know? We know that we have a fair market value of $10,000 today. So let's take that as our focal point. And we're going to be pulling this money back, or sometimes people will call this discounting. We're going to discount our equivalent payments such that when we add them up, we should get a fair market value of $10,000. Now, both of the rates here are 4%, and I think the timing is very straightforward. Our first calculation will deal with t is equal to 1, so we're going to have to discount or take away 1 year of interest. And then for our second equivalent payment, we'll have to take away 2 years of equivalent of interest. So t is equal to 2 in that second arrow. Since both of the arrows are pointing towards the left, that implies we should be using the present value formula for simple interest. So let's go ahead and do these 2 calculations. We're going to take x as the future value, and we're going to be discounting that money. And in our first arrow, we have a rate of 4% and a discount needed of 1 year's time. And so what we end up with is x divided by 1.04. And that's kind of an awkward thing to work with in the next step. If you remember from the last kind of equivalent problem we were working with, we have this step where we have to add up everything and then do a division. So that's kind of our last step. And I don't really want to bring fractions into the mix in this last step. It makes things a little bit more complicated. So what you're going to see me do here with this 1.04 is I'm actually going to do a division. So this is something very similar to what we did on test number 1. And I'm going to think about this as 1 divided by 1.04. And I'm going to grab that decimal number that I get from doing that calculation. And I know it's going to be a bit of a pain in the ass, but we do have to take a significant amount of decimal places. You want to make sure you take enough that you're going to be within 5 cents. So I always tell students, if you don't know how many to take, if it's not obvious how many decimal places to take all 9. So that's what I'm going to do here is I'm going to do this division. I'm going to get 0.96 and some other numbers, and we're going to roll with that decimal number when we go to that last step of the problem. And I do want to show you a little bit of a kind of a fun use of the 1/x button. So for those of you that have your business calculator, you can actually use the 1/x button to do a little bit of this work for you as well, if that's something that makes sense to you. So let's say I put in the number 1.04. So I'm going to put the denominator in. What the 1 over x button does is it moves that number into the numerator. It does the division of 1 divided by 1.04 for us. So if I actually press that 1 over x button, it'll give me this decimal number that I need right away. So that's actually quite powerful. It's a little bit of a faster way, I would say, to get to that decimal number if you need it quickly. Okay, we're going to set up and execute something very similar for number 2. We're going to take x as our future value, and then we're going to divide by 1 plus our 4%. Only this time we're going to have a 2-year kind of discounting that we need. And that's going to give us x divided by 1.08. And so once again, you can just go to your calculator. You can do 1 divided by 1.08, or you can use the 1 over x button. It doesn't really matter to me. But hopefully you should be able to convince yourself that we get the following decimal number. So 925, oh, it looks like repeating, 925926. So that's going to be the decimal number that we need in front of x. So how are you guys doing? Does that setup make sense? I find that these ones where we have to do the principal value a little bit, they just feel a little bit more awkward because you get the kind of 1 point something in the denominator, and they're just a little bit weirder to deal with. But let me know if that makes sense, or if you have kind of like a question or just need a little bit of clarity on something. Okay, great. So I'm getting a couple thumbs up from the chat. Perfect. And like I said, you can use that 1 over x, if you wanted to set this up as, this fraction plus this fraction equals 10,000, you can use the 1 over x button to kind of make this a little bit easier for you. And I can show you how to do that in a second. But the last step essentially is to say, well, we know that the fair market value today of this investment stream, this payment stream, is going to be $10,000. And so what I need to do is I need to add up what I've calculated in part one and part 2. When I add those things together, the fair market value should be $10,000. Okay, so it's a bit of a writing to do here, but let's add up these 2 large decimal numbers. Okay, I'm just going to do that in the background here. So just maybe verify this with me and make sure that I haven't made, it's really easy to make a mistake when you're working with these really large decimal numbers. 6. So I get something like 1.887-ish. And then similar to our last example, once you're happy with this decimal number, we're just going to divide both sides by that large decimal number. And that should allow us to solve for x and figure out how much money I'm actually going to get during each one of these kind of yearly payments. Yeah, perfect. That's what I get as well, Kate. So that's a good verification. So $5,298.11. Awesome. So hopefully you guys can also receive that same value. Let me know. I'll just kind of float this up here for a few more minutes in case you need to copy down some stuff. But yeah, make sure you can kind of work your way towards this 5298.11. Awesome. So Holly says yes. Wait, is there a way to get different colored thumbs ups? How do you get different colored thumbs ups? Oh, what? You can change the skin tone. That's fun. I didn't know that. You know, you learn something on Zoom every day. You know, you're always learning. So Garrett, I assume that yep was you were happy with the 52.98.11. I didn't know this until last year either, but apparently you guys can annotate the screen if I give you permission to do that. Oh, here it is. Security. Hello, participants, unmute start video. Yeah. Yeah, see, there you go. You guys can annotate the screen. So I mean, if you're ever asking a question and I'm not and I'm too dumb to figure out what the heck you're trying to ask, if I can't figure it out, you can always put a mark somewhere and kind of show me what you're looking at. I forgot to let you guys know that when we were kind of you know, working through stuff earlier. But yeah, you guys can annotate the screen if that's something that that is a helpful thing for you in the future. Who put this mark here? Get that mark out of here. Can you erase your annotation? I don't know. Get that black mark off my screen. Okay. So I'm going to pop up the next screen so you can start copying some of the little notes that I have here down. We're going to be moving into a different kind of interest. So this is kind of the last kind of main topic is called the compound interest chapter that we need for test number 2. So today I want to show you how interest is calculated and how we develop the future value formula essentially, and kind of where that comes from, how it looks, how it's going to kind of feel similar to simple interest, but it has a couple of weird quirks associated with it. So the big difference is given here at the top. So, you know, whenever I ask students, what's the big difference between simple interest and compound interest, I really want you to know that for simple interest, you only can ever earn interest on the principal amount, unless at some point in time you pull that money out and reinvest it somewhere else. You know, then there's going to be a new principal amount that you're earning simple interest on. But if you throw your money in and let it sit there for 5 years, you're only ever earning interest on that starting amount, right? So that's the big difference. In compound interest, we develop these kind of time steps or time stamps in which we're allowed to earn interest. And as soon as we've earned interest, then the bank will calculate the initial investment plus the amount of interest in dollars that I've earned, combine that, and it's almost like they've reinvested it all over again. And during the next time step that we decide on, the bank again is going to allow us to earn interest on this new amount. So compound interest always has the possibility of earning interest on the interest in dollars that we make over the course of time. So that's the big difference. Now, what the banks typically won't tell you is how they kind of fudge around with the interest rate a little bit, but we will get there in a moment. And so the big formula right off the hop that I want you to know about is the following. How do we calculate interest in dollars for compound interest? If I'm working on an issue or a problem where I'm dealing with compound interest and I want to know how much interest in dollars I'm going to make after one compounding period. So this is really important here. This particular formula only tells me how much interest I'm going to make after one of these compounding periods. I'm going to say like, and we kind of think about them as a time step. And if you've had a chance to kind of read through the textbook or do a little bit of looking through the online textbook, it's kind of tied to this idea of a frequency number. So there's a frequency number, we call that F. So F here stands for the frequency number. And F essentially tells us how often these time steps or how often these compound periods happen. So if I were to say something like 3% compounded monthly, then I know that the frequency is 12, or I'm going to be compounding my interest. I'm going to be earning interest 12 times throughout the course of 1 year. Did you guys have a chance to look at some of the terminology associated with the frequency number? So if I said, compounded quarterly or compounded semi-annually, are you familiar with those kinds of words? That's going to be really important for this section of the course. Okay, I have quite a few yeses in the chat, so I don't want to take too much time. I'm hoping that after you kind of work through some examples, you'll see how this frequency number is important. But essentially what the bank will do is they'll give us what's called a yearly rate or a nominal rate. We're going to call that little r. So they'll say something like 3% compounded monthly. So this is how much interest, like this is the percent added up over the course of all of the compounding periods that I get. So what they actually do is take that yearly rate, they divide it by the frequency amount, and that's actually the amount of interest that you earn during one of these compound periods. This is known as little I, and we'll talk about this. So this little I number, which is R divided by F, is what we call the periodic rate. It's the actual interest rate that I get during one of these compound periods. Capital P here still stands for our principal amount or our initial investment. And this capital I, just like simple interest, stands for the interest that we make in dollars. Okay, so there's two kinds of rates for compound interest. There's the nominal rate, which is kind of the yearly rate that's typically given by the bank. And then there's a lowercase I that we call the periodic interest rate. So maybe worthwhile to write that one down here as well. So I, which is equal to R divided by Fi, is called the periodic rate. And this is the actual interest rate that I get during one of these time steps. Okay, so just like the nominal rate, the periodic rate is a percent. It's the percent interest during one compound period. That's one way to think about this little I. So let's go ahead and work through what I'm hoping are going to be some helpful examples. Oh, interesting. How is audio quality for you guys? I just got a little pop-up. Okay, so it's still fine? Okay, that's great. I just got a little pop-up from Zoom saying, close some stuff. And I'm like, I'm literally sitting right beside the internet. So I don't, I'm like, I don't know, I could literally be lying on top of my router, but I'm as close as I can be to my internet service, that's for sure, so. Yeah, and that's the hard part about online classes, right? You have to actually really be mindful of the internet capacity power. I wasn't sure if I was going to be online or face-to-face. When I moved in the spring, we didn't really know as a college what was going to happen. So I'm like, I need to get like a really good, internet service provider with all the bells and whistles. So yeah, sitting here, I don't usually have too many troubles at home compared to the college when delivering these courses online, which is nice. So let's work through what I'm hoping will be a nice example to show you kind of the difference between like how simple interest works and how compound interest works. So what we're going to do is we're going to set up a situation where we're going to invest $500, and our $500 is going to go through 2 years of earning interest, okay? And what we're going to do is we're going to give it the same rate of 5%. So we're going to do it for 5% simple interest. And then we're going to do it for 5% compounded annually. So a rate that would be very similar to my 5% simple interest. And we'll take a look at the difference. Like how does simple interest look a little bit different compared to compound interest. And so we've been working with simple interest for a while. So, I mean, we can just use the future value formula to get the final answer if that's something we want to do. But let's actually really break this up into the two different years and then kind of determine in kind of a really long way so we can make really nice comparisons how much interest we're going to make over the course of 2 years. So if I'm not curious, right, if I don't need to know exactly what the future value is, I don't need to skip to that right away, I can just use the PRT formula. So capital I, this is how we calculate the amount of interest that I'm going to make over a certain amount of time. So if I'm going to put $500 into the bank and let it sit there for 1 year, I can essentially just say, here's $500. I know my interest rate is 5%, and I'm going to put T is equal to 1. Okay, so this should tell us how much interest I make in the first year with regards to simple interest. Is that a nice number? I feel like this is going to come out to be a super nice number. 25 bucks. So after 1 year's time, we know based on what we've talked about with simple interest that we should earn $25 on this investment. Now, knowing that, how much interest are we going to make in year 2? Do you guys remember? So how much interest, not in total, just how much interest just during year 2 am I going to make? Also 25 bucks, right? And the idea here is, I haven't pulled this $500 out and reinvested 525, like the 500 is still just sitting in there. So the interest is still going to be the same in year 2 because we're dealing with a simple interest kind of situation. So year 2, we're also going to earn $25. Okay, so in total, our future value should be 500 plus 25 plus 25. So if you did happen to use the future value formula, you should have got $550. And then from there, you can be like, okay, well, the 500 is my initial amount, so I earn 50 bucks in interest over the course of 2 years. So hopefully that makes sense. Hopefully that's not a mystery or weird or anything. Like that's how simple interest works. And I feel like we've talked about that for, at least a week and a bit. So hopefully that's okay. Now, what some of you may not know right now, if you haven't kind of worked with money before, is how to treat compound interest. So how does compound interest work with regards to kind of the same parameters? So a 5% annual rate and depositing the same amount of money. So it's a little bit of a different formula, but essentially what I've done is I've forced our time steps to be 1 year. I've essentially forced our compounds to happen just at the end of the year only. This is going to be a yearly one, Luke, just so because I really want to compare it to simple interest. So I want this first year to basically look identical to simple interest. So we're only going to earn interest at the end of the year. That's it. That's what compounded annually means. In other words, we earn interest one time. So I earn 5% interest at the end of the year. That's it, that's all. We're not going to divide this 5% up into smaller pieces and distribute the interest that way. But we will take a look at a couple examples in the future where we will do that. We'll do some monthly, we'll do some, hopefully some weekly or bi-weekly stuff. So you guys can see how this F number kind of ties into the formula. Right now, if I just kind of use my compound interest formula over the first compounding period, which is year number 1, I'm going to deposit 500 bucks. I know my rate is 5%, and I'm compounding 1 time per year. So I'm really just going to be taking $500, applying that 5% rate, and it should give us the same value, the same interest as we saw for our simple interest case in year 1. So that's what I'm trying to do. I'm trying to set us up into a situation where at the end of the year, I have the exact same interest in year 1 as simple interest. And it's really year 2, because of the scenario we've set up, where we start to see the change happen, because now what the bank will do is it's going to take our $500, it's going to take our $25, and it's going to add them up. Okay, so all this is kind of happening, in their database in the background. If you work with a banking system, at the end of the month, if you've earned interest on something, they will give you that interest. They're going to add everything up, and they're going to use that number as the next capital P. So this becomes now our principal amount during the next time step. In our case, it's year number 2. So as I go to calculate my interest during the second year, I need to actually use $525, because that's kind of my new investment that the bank has just kind of reinvested for me. And then I multiply by R times F, or R over F. And yeah, we should get something a little bit more than what we had before. Like, I think Andreas has the right answer here. So we're going to multiply by our 5% over 1. And yeah, I do think we get $26.25 after year 2. And that's the big difference between the two interest systems, is that when you're compounding, you always have the chance to make more money on an investment. Or if you're taking out a loan, the bank has more of an option to get more money from you when we're working with compound interest. So altogether, our future value in this particular, so if we wanted the total, our future value would be our initial $500 plus the $25 plus our $26.25. Yeah, so we end up getting a little bit more, not by much. It's only by $1.25. I mean, you can't even buy a good coffee for that. I need at least, maybe a few more pennies to get a good McDonald's coffee, but hopefully you see the difference, right? The big difference is the interest that I make when I'm working in a simple interest kind of scenario is always consistent every year, every year, every year. The interest that I make in a compound interest kind of scenario compounds on itself, right? So that, I think that's why they called it compound interest, because the interest that you make always has this capacity during the next time step to make more money for you. Yeah, hopefully that makes sense, and hopefully this helps illustrate that idea on how the bank treats these compounding periods, right? So it really comes down to, hey, how much interest did I make? Let's add that to the principal amount, and then let's use that as the new amount in the second step. That's kind of the idea. That's kind of the thought process of compound interest. Let me know. I know that some of you have kind of said, hey, that's cool, that makes sense. How are the rest of you feeling about that explanation? Does that help kind of clarify the difference between the two? Like, was that, I don't know, was that helpful, or did that just bring up more questions? Sometimes I say stuff and I don't know if I'm making sense. Okay, thank you very much. I appreciate you guys for looking out for me. I appreciate you letting me know. Okay, well, I mean, let's talk about how we actually transition from this interest formula into the future value formula. So we want to start working away at trying to get to a formula that's going to kind of do what we did for simple interest. Like, yeah, it's nice to use PRT, but in some instances, it's better just to know the FV formula. So what is the FV formula? How do we get there? And so what I'm trying to argue here is that the future value after a single compounding period is always going to look like this. My future value is going to be the principal amount plus whatever interest I've earned during that first period. So we can see that here, right? So the future value after one compounding period is the principal amount plus the amount of interest that I've made, 500 plus the 25. So if that's the case, we can essentially just say, well, I know that I is equal to P times R over F. So we're just going to make a substitution for I. And then that allows us to factor out capital P. And so we end up with something that looks like this. We get the principal amount times 1 plus R over F. So this is what we call the future value after a single compound period. That could be after 1 year, could be after 1 month, could be after 1 week. It depends on the structure of the interest that we're making. And I'm hoping that, you know, some examples we do will clarify that. It really depends on this F number. It depends on this frequency number. So that's what we get after a single compound. And then what happens is the bank takes that future value and treats it like the new principal amount. Okay, so you can kind of think about it like, hey, I'm going to calculate the future value after a compound period. Then I'm going to take that money, I'm going to reinvest it again so that I can earn more interest during this second compound period. So that's kind of what we're getting set up to do here. Hopefully that makes sense. What this expression over here is doing is allowing this new principal amount to make more interest during the next compound period. And for those of you that are algebraically savvy, you can see that you actually end up having two terms. I'm going to underline them in red. So both of these terms inside the bracket happen to be the same number. So we can combine them together to get the following expression. The principal amount times this kind of interest bracket squared. And that's really important. The important part now is, hey, now that becomes our new P. We multiply once more by 1 plus R over F during the next time step. So it appears, based on kind of the pattern that we're seeing here, that at every step, at every compound period, we're just multiplying by 1 plus R over F. So essentially, after n number of times that we get to earn interest, we would have the following formula. And that formula is given right here. I'm going to just outline these formulas in black because it's not the full finalized formula that, well, this one actually is. So the textbook is going to use this as its full finalized formula, but I think you can do a little bit better. I think we can make it a little bit clearer in class together what I is and what N is if you're using the hard copy of the textbook. So the periodic interest rate, I, is always given as the yearly rate divided into F equal parts, F equal bins, because we're essentially dividing that yearly rate up into F compounding periods. So I is equal to R over F. Personally, I like using R over F in my formulas. I think it makes it a little clearer based on the numbers that we have in the question, how to substitute into this formula. Now, N here, remember, N represents the number of compound periods. So right now, I don't think it's too obvious how to find N, but I'm hoping after we do a couple questions together, it'll become a bit more obvious how we break N down and what makes it, you know, what pieces I need to multiply together to find this number. I think that's usually the hard part. So the hard part in compound interest is one, figuring out what to divide by, right? Remembering to take your rate and divide by something. That's hard. And then the second hard part is typically trying to figure out what N is. So I'm hoping to demystify how to calculate that, because I don't think the book does as good of a job as it could telling you how to calculate N. By the way, if you want to make a note for yourself, N is always a whole number. You know, until we go to solve for N, that's a bit of a different ballgame. But for now, we're going to assume that N is a whole number. Like the bank is not going to be like, hey, come get, you know, some monthly interest, and then, you know, it's probably not going to prorate that interest for you. You know, like banks really aren't into you know, skipping out on them halfway through that month. I don't think they'll give you that interest. So we're kind of taking N to be a whole number in this particular case, so that we're not really going to be prorating compound interest. Either, you know, you have the money in when that interest comes in, or you don't have the money in when that interest comes in and you're kind of shit out of luck. Okay, so I did put that note down here for N, total number of compounds. And then here's a little note talking about the periodic rate if that's something that that you want to have a definition for. So the periodic interest is essentially the amount of interest we earn during one of these time steps only. It's not the yearly rate. When we add up all of the periodic interest, we should get the nominal rate or the yearly rate. Okay, so I really do want to try to work through as many examples as we can for the rest of the 12 minutes that we have, so you can kind of get a feel for how to start inputting some of these numbers into the formula. And then we're going to do a shoot ton of examples on Thursday's class. I'll have a bunch of examples of calculating a bunch of different things for you guys on Thursday's class. We'll have a full hour of just no notes, all examples all the time. Today's class is brought to you by Muscat, by the way. Delicious, vibrant grape varietal, often known for having very voluptuous aromas on the nose. Can you tell I used to work in the wine industry? Thank you. I'm glad somebody's at least laughing at my absurdity. Thank you. I appreciate you, Steph. I can't remember if I told you guys, but yeah, I did used to manage wineries over the last couple of years. So not last summer, but pandemic summer #1 and the summer before the pandemic started, I worked as a manager at wineries in Naramata. So if you've been to the Naramata Bench, I used to manage Bench 1775 for one summer, and then I managed a smaller winery called Joie Farm as well. So those are the two wineries I've worked at. If I had stayed in Penticton, I probably would have worked at Little Engine as well. I had a connection to the owner there, so I was hoping to work there last year, but we ended up moving to Kelowna because of the opportunity to teach at the Kelowna campus. So yeah, most people do know Bench 1775. They're a pretty big winery. They have a pretty big production, I would say, and a lot of international affiliates as well. Heather's maybe running to the store tonight. Well, let me know what you get, Heather. Let me know what you get on Thursday. Let me know if you like it, and maybe I'll buy some too. I typically go to, let's see, there's certain regions that give you pretty good bang for your buck. So like if you go into usually Argentina, Chile, if you're really good at finding stuff, sometimes Italy can have some very good price points for the quality of wine. Spain can sometimes have very good quality for the price. But it just depends what you want to buy. I find BC wines to be a little bit more expensive because there's a lot of care taken into producing wines here in British Columbia. So they have to charge a little bit more because of the kind of lower yields and the more work that typically goes into to making these wines. Okay, hopefully we're all in a good enough place now to start working away at this example. We have an initial investment, $1,250. It can earn 5% compounded monthly. That's a very common kind of compounding, a frequency of 12 times per year. Okay, I want to ask a couple questions. The first question is, what is the periodic interest rate? So how much interest do I actually make every month? After we get that, how much interest is earned after the first month? So how much interest in dollars? And then finally, what is the future value after 3 years of investing this money? Cool. So let's divide this up into 3 parts. The first part is asking us, what is the periodic interest rate? So if I'm curious about how they're dividing up this 5%, I just need to know some information about the frequency number. So what they're doing is they're actually taking 5%, breaking this up into 12 equal-sized pieces, and that's the interest that you make every month. That's what 5% compounded monthly means. It says take 5%, divide it into 12 equal-sized parts, and this is what we call the periodic interest rate. Okay, so I get a decimal number like 0.004167. I really just need this to a couple decimal places, so we could say like something like 0.42%. So it's a pretty small amount of interest I'm getting. 5% from my perspective is a pretty good interest rate. Like most interest rates right now are much lower than that, compounded monthly, right? And you can kind of see that, the banks are advertising this big interest rate of like 5%, but you're really only getting 0.42% over the course of 1 month. That's what this periodic interest rate means. All right, maybe you're curious about how much interest in dollars you're actually going to make after that first month. So let's take a look. I know that I can calculate the interest in dollars over the course of 1 compound period by determining what the principal amount is. In our case, since we're curious about just the first month, let's take $1,250 and let's multiply it by this periodic rate of 0.05 over 12. And doing that, I get like $5 and I don't know, 21 cents. I think that's rounded correctly to 2 decimal places. So in other words, if I take that principal amount of $1,250 and I multiply by that periodic rate that we found up above, which is 0.0042, we should get about the same amount. I know it's not going to be like perfect, but it's a little bit off, but it's close enough for our course. We need to be within 5 cents, and it's really just the rounding error here. But that's all that's happening is we're taking our $1,250, we're multiplying by the periodic rate. That tells me how much interest I make during a compound period. It's not the 5%, unfortunately. It's the 1/12 of 5%. And then finally, we can use the future value formula. So let's take a look. So the future value formula is P times 1 plus R over F times N. So they're asking, what is the future value after 3 years? Okay. 3 years. So 3 years is going to help us determine the value we need for N. How many compounding periods, how many times do we actually have to earn interest over the span of 3 years? How did you get 12 times 3? You are correct. I'm not saying you are incorrect. This should be 36, N should be 36. And what I want you all to understand is, how do we get 36? So 36 comes from the fact that in 1 year, I have 12 compounds that happen, 12 chances to make interest. So after 3 years, I should have 36 chances to make interest. Yeah, so we're compounding monthly, 12, over the course of 3 years. So 12 times 3, N should be 36. Okay, so this 3 years tells us that N is 12 times 3, which is 36. And that's what we're going to roll with for this particular calculation. Okay, so we're going to put in our principal amount of $1,250. We are going to multiply by 1 plus the rate over the frequency number, so 5% over 12. And we're going to input 36 here for N. And let's see, how comfortable are you guys with putting that 36 in? Do I have to show you how to do that on the calculator? Well, how about I put up what I get for a final answer? I'll put up what I get for a final answer. You can let me know if I'm way off or not. So first, let's try to verify that that's correct. And then if we need to, I have access to the calculator app, so I can show you how to do that if that's something that will be helpful. So Holly Is your yes meaning you would like to see the calculation or that you got the 1451? Please show. Okay. Okay, I'm going to share my screen. And in that way, you should be able to copy down anything you need to. And then kind of follow along. So I'm going to be looking at this particular line right here. And the key is when I go to put this in, I need to use the Y to the X button, and then I'm going to hit 36 equals after that. So what I'm going to do is I'm going to start by putting in my 1250. So I'm going to put in my principal amount. You do have to put a multiplication symbol here, I believe. So you have to multiply and then put the bracket in. And then I'm going to kind of put in all the numbers in the bracket. So 1 plus 0.05 over 12. I'm going to close the bracket. And then I'm going to hit the Y to the X button to get the power in. So Y to the X 36, and then hit the equals button. Okay, so put in your principal amount times bracket, all of the stuff, close your bracket, Y to the X 36. Okay, awesome. You are welcome. And yeah, if you need to, like, this is going to be posted up a little bit later today. So if you need to go back and write something out for yourself so you know how that works, please feel free. We probably aren't going to have, you know, I mean, if you guys have to go, then you can go. But I do want to finish this particular question, and then I'll post it up. So if you got to run because you got places to go, people to see, that's totally fine. You're not going to offend me in any way. If you have any questions, throw them in the chat before you leave and I'll address those questions. But I do want to finish this last example. And that way we're kind of ready for the 3 other formulas that we need to talk about on Thursday. And so I'll let you take a few minutes just to kind of either take a photo of that or copy that one down. And I'm going to start working away at how I would go about these particular questions. By the way, we can probably develop that formula right now. So how did Andreas know that it was 36? Well, n is equal to the frequency number times a yearly kind of number. And I think that's important. So this is what I would consider to be the fully flushed out future value formula. Take the principal amount, multiply by 1 plus r over f. And n can actually be calculated by multiplying the length in years times the frequency number. So this is kind of my preferred way to think about the future value formula for compound interest. It gives me a little bit more insight into how do I calculate I and how do I calculate n. All right, so I'm going to blast through these last 2 calculations fairly quick for us. In number 1, we are looking for the future value of $1,000. So that's my principal amount. 1 plus. So I need to now look at the compounding structure. So R is 4.5%. And we're compounding monthly. So I know F is equal to 12. Now, the last thing I need to get the power that I'm going to be using over here, and I'm going to be using 23 months to do that. So in green, I'm going to do a little calculation for n. I know that n is t times f. So how long is this investment going to sit in the bank? It's going to sit in the bank for 23 months. 23 over 12. What's the frequency number? The frequency number is 12. So altogether, it should go through 23 compounding periods. So if it's not obvious from the question, you can always rely on this formula T times F to figure out what we need to put in for n. And n should always be a whole number. And if someone can verify for me too, they get $1,089.90. So just let me know if that seems like a reasonable answer. Okay, so Garrett can verify that, and that way I can just kind of jump into writing down some points about number 2 here for you guys, so we can kind of finish up the class today. Okay, awesome. So everyone seems like they're able to get that. So this is a bit different. We have 7.75 compounded weekly. So what's F in this case? So it's 7.75 divided by what? What am I going to put here? What does weekly mean? There are 52 weeks in 1 year. So we're going to take the 7.75, divide it up into 52 equal-sized parts. Now, we get some information about the length as well. So if I want to figure out what number I need up here, I can multiply T times F. In this case, we have 5 years. T is always given in years. It's going to be big. It's going to be like 260, right? This is a weekly compound now. So it's 5 years, every week for 5 years. Yeah, oh, no, no worries, Garrett. This is, like I said, this is always the hardest part, is figuring out what this power is. So I believe the power here should be 260. We're going to have the chance to earn interest 260 times. Okay, and in this particular case, I get $1,472 and let's say 87 cents, rounded to 2 decimal places. Okay, so that's really essentially everything I wanted to show you about the introduction to compound interest. So let's be prepared on Thursday to do some calculations with the principal amount, do some calculations to get the periodic interest rate, little I, and do some calculations to find N, which is kind of like the length or how many compound periods we go through. Yeah, no worries, guys. Sorry that I kept you for a couple extra minutes here, but I really wanted to get through the future value stuff. Hopefully, yeah, hopefully it helped you kind of clarify some ideas. So thanks for kicking around for an extra couple minutes. I appreciate it. Yeah, you guys have a great day too. Thank you so much, guys. Like the fact that I get, yeah, you're welcome, David. Hey, no worries. The fact that I get so many of you coming to an online class makes me so excited. You know, like I get bye. Yeah, I get so happy about that. I get so happy.
Thank you very much. Have a good one.
You too, Emily. Thank you. All right, guys, have a great rest of your day. I will see you on Thursday.
Thanks,
You're welcome.